Today, we're going to be looking at the carbon-carbon spectrum and how this can help you determine if a signal that is missing a peak is supposed to or not supposed to have a peak on it. We're also going to be looking at the transfer/assign peaks tool and how that's going to allow you to move a lot of peaks from one spectra to another. So the first thing we're going to want to do is two-letter code SP, open up strip plot. This is going to make moving around our 3D spectra a lot easier. And we're going to, of course, select the strips that we want, as you normally have to do every time you open strip plot. And once we have our 3D spectra selected, we can go ahead and select a peak under investigation. This is going to happen as you move through and try to assign your spectra. I already have one here under investigation, so I'm going to go ahead and click peak. Now I'm going to zoom in and widen this spectra quite a bit here because there are a lot of peaks to investigate. We're going to see that here. So we can see that every one of these signals has no peak on it, and that's strange and that's odd. But one of the ways that we can find out if there were supposed to be peaks here or if they were intentionally left out by our automated peak picking tools, we're going to come to this area here that corresponds in the CC. It's the upper left. We can just go ahead and zoom in on that. And we're going to be checking to see if these peaks in our 3D spectra, or these signals in our 3D spectra, correspond to a peak in the CC spectrum. So we can see right here, this peak very nicely corresponds to, or this signal nicely corresponds to this peak here. And so that is one that we can consider a success and we can transfer over. But we're also going to look at the rest of these signals that do not have peaks on them here. We can see this one's fairly close, but it is just off of that signal, and this could be a peak resulting from somewhere else in a different nitrogen dimension. And so I'm going to go ahead and leave this out. We can check this one, corresponds to a nice peak right there. Check this one. This peak could result from this signal. We'll transfer it. And we're going to have to scroll down here just a tad to see this one. And of course, it is up to user if these peaks correspond well enough or do not. I'm going to consider this one a success and transfer that as well. And we can see here that this peak looks like it has been assigned right there. So we can go ahead and not worry about that. Now that we have the peaks that we think should be transferred over, we need a way to transfer them. And so we're going to go back and we're going to use two-letter code capital T, capital P to open up our transfer/assign peaks window. Of course, one of the major things you want to do right away, select your to and your from. We are selecting peaks from our CC and to our NCOCX. So now we need to select how our different dimensions line up. So here we have our nitrogen dimension. There is no nitrogen dimension in our CC, and so where we want these peaks to end up is our current Z-plane. That is the plane that we are looking at in this spectra here. And then the other two need to be lined up properly. And what we can do now is we can keep this box here, use selected peaks only, clicked, because we do not want to select every peak in the CC to put on this plane. So we are going to go and select those peaks that we want to transfer. So there is a peak here. And a peak here. We have decided not to transfer this peak, And our final peak is the one right up here. And we have that one. All right, so now that we have all of the peaks selected that we would like to transfer over, we are just going to go ahead and click. Make sure you have the 3D spectra selected. That way the transfer/assign peaks window will know what your current z-plane is. And just go ahead and click the transfer button. And what we can see has happened here, we'll zoom in a little bit. What we can see has happened here is all of our peaks have been transferred with a label of ? And that's just to allow the user to know that this is a peak that was transferred and to differentiate it from the rest of the peaks in the spectra. So from here, now you know that there should be a peak on these signals or somewhere close to these signals, and you can go about the rest of your assignment. Hope that helped.